Hi, this is Peter with CalcBook, and today we're going to be looking at concrete punching shear. So we do a quick recap on our punching shear, right? We have this foundation here with a depth D, right? This is also sometimes called two-way shear. The cracking starts at the tension face, so in this case it's the bottom of the foundation as the pedestal pushes down and extends towards the compression zone, which in this case is our pedestal. And it fails at a 45-degree angle. And when we calculate the capacity of our two-way shear, we calculate the capacity at the critical perimeter, which is going to be at a distance of d over 2 from the face of the pedestal, and in this case d is the depth of the foundation. Right, and two-way shear commonly occurs in foundations. It occurs in elevated slabs supported by columns, and then also similar to foundations, a column on top of a slab. And we calculate our two-way shear capacity in accordance with ACI 318, chapter 22.6. So we have a quick example here. We're going to go into CalcBook and look at the punching shear specifically, but our setup here, we have a spread footing. It's a square spread footing, 8 feet in both directions. It's 1.5 feet deep. It has a 1.5 foot square pedestal. No eccentricity. It has no moment or shear, just vertical loading of a dead load of 10 kips and a live load of 20 kips. So let's go ahead and open up CalcBook and we'll get started on the design. All right, we've got CalcBook open now, so we can go ahead and take a look at our inputs. We've already entered in all the necessary information from our problem statement. We've got our footing set at 8 feet square. We've got our depth of footing at 1.5 feet. And then we've got our pedestal at 1.5 feet square as well. We've got some other information here, but for punching shear, we do not need to adjust anything. If you're interested in a detailed, front to back spread footing design, check out our YouTube channel with more information. We have a full spread footing design front to back for you if you want to see that. We've also got our demand entered here. We've got 10 kips of dead load, 20 kips of live load. And then we go ahead and take a look at our design summary under the two-way shear row here. We've got a demand of 62.64 kips and a capacity of 324.75 kips with a DC ratio of 0.19. So let's go ahead and jump into the design here and we'll take a look at some of these things. So first thing, let's take a look at our demand. So if we go down to our strength demands, right, and we go to our two-way shear demand, we can see we have a controlling load combo of 1.2 dead plus 1.6 slab, which makes sense because those are the only two items that we've entered. And so what we need to do is we need to calculate the bearing pressure utilizing our LRFD load combinations. So that's why we're using this 1.2 dead plus 1.6 live. So we get our bearing pressure based on LRFD load combinations, and then we use that to determine what the force is on that critical perimeter, which we'll get into in a second here. So we figure out our two-way shear demand of 62.64 kips. So now if we go down to our capacity calculations, right, we've got a few things to step through here. The first thing is our size modification factor for punching shear. We have a factor there of 0.9. Then we check our long to short ratio of the pedestal. In this case, it's a square, so we just have a 1. And then we check the critical perimeter, right, the punching shear perimeter. And that comes out to 130 inches. That's the length of this perimeter here, d over 2 from the face of the pedestal. And then for the capacity for two-way shear, we have 3 equations that we check. So we check 22.6.5.2a, b, and c, and then we take the minimum of those equations. And in that case gets us a nominal capacity of 433 kips. We don't have any additional capacity due to steel reinforcement, so V sub s is 0. And then we take our nominal, which would be V sub c and V sub s. Again, V sub s is 0, so it's just 433 kips. We apply our phi reduction factor and gives us 324.75 kips. So that is a quick recap of punching shear utilizing CalcBook. If you want additional videos or you have questions on this video, please let us know in the comments below, and we'll see you next time.